Idea. Today we will see the dispersion of white light by a glass prism and recombination of this dispersed light. Okay. Last is what we have seen this refraction of light through a prism. So what happens when there is a refraction of light through a prism? There we have found some angle of deviation from the incident ray, okay, which is produced forward, right? So that's angle of deviation. We have seen the factors which affects the angle of deviation also. The main factor would be the refractive index and also the wavelength of the light. We discussed the day, that is, if the wavelength of the light is small, it decreasing means then the angle of deviation would be more. Okay, so yesterday we sent only one light, right? So this is your prism. We sent any one particular light. If it is not there, it will be produced like this. Since it is passed through the prism, so it is refracted, right, slightly. Since it is this is your normal. When it is entered from rarer to denser medium, it will bend towards the, instead of going like this, it will bend towards the normal, because this is your normal. Okay, this is your normal, and then it will be emerged out again. This is your normal. It will be away from that. Since it is passed from denser to rarer, it is away from the normal. So this is the path of the refracted light. Okay, we have used only one light, okay, one color light. So it is this is your angle of deviation. When it is produced back, this emergent ray, this angle between the incident ray and the emergent ray is your angle of deviation. Okay, we have discussed that when the wavelength of the light is decreasing, the angle of deviation will be more, right? So here today we are going to see the disperse of white light by a glass prism. Okay, so we found that this, based on the experiments, it was found that white light is composed of 7 different colors. Okay, white light is composed of, if you are seeing any white light, means it is a combination of 7 different colors. Okay, the colors, the order of the sequence of the color will be the 7 colors would be VIBGYOR. You can remember by this first letters. Okay, VIBGYOR. Okay, V stands for violet, indigo, blue, green, yellow, orange and red. This is your VIBGYOR. This is a sequence of the color based on the wavelength. Okay, this violet has a minimum wavelength when compared to the red. Red has more wavelength, maximum wavelength. Okay, okay, if the wavelength is more means what? Deviation, angle of deviation will be less. Angle of deviation will be less. When the wavelength is minimum means the angle of deviation would be more. Clear? This is what we have discussed in that. So from the experiment they found that white light is composed of 7 different colors, and this is so it is increasing towards this. Okay, wavelength would be, so based on its wavelength the deviation will differ. Okay, so each color will have a different deviation capacity. Okay, deviation amount. Okay, so when the light is passed through this, see, a prism, this is a prism. Okay, when a beam of light, okay, a beam of light, white light, this is your white light. This is your white light. When it passed through this, we know that it contains 4 different colors. Each color had different wavelength. Okay, okay. So when it is produced like this, when there is not prism, it will be produced like this. So because of this prism, it gets the deviation. Since it passes from rarer to denser, so it will be move towards the normal. This is your normal. Instead of going like this, it will be moved towards this. Okay, okay. So this and all the colors will be 1, 2, 3, 4. We'll draw one more here. 5, 6. 1, 2, 3, 4, 5, 6, and one more is 7. Okay, you are able to analyze this. What color of this line would be? Since the deviation from this line, incident light will be, see, your emergent light will be like this, right? Away from the normal. 1, 2, 3, 4, 5, 6, 7. Okay, if you produce back, this is your angle of deviation. If you produce back, this would be your angle of deviation. Okay, what color it would be? Come on. So since it is less deviation, means it has more wavelength. Which has a more wavelength? The red color. This would be your red color. Okay, this last ray has more deviation. See, if you extend this, you will have this much of deviation, right? If you extend forward, you will get backward, you will get a more deviation. More deviation means the wavelength should be minimum. So which has a minimum wavelength? This would be your violet. Okay, so this would be your indigo, blue, green, yellow, orange, and this would be your red. Clear? This is the dispersion of white light by a glass prism. Okay, because since the white light consists of 7 colors and each color has different wavelength, okay, each will have a different angle of deviation from the incident ray. That is the reason you are getting the different colors. You are able to see all the 7 different colors separately, distinctly. How? Because the angle of deviation for each light will differ from other. Okay, that's why you are getting a 7 different colors. Okay, this is the dispersion of light by a glass prism. Okay, so how will you give the definition for this? You can give the dispersion of light. It is a phenomena of splitting of white light. Okay, we are going to split the white light into its 7 components when it is passed through a prism or any other object. Okay, dispersion of light is the phenomena of splitting of white light into 7 components when it is passed through the prism or any other object. Okay, clear? Next, what is spectrum? Spectrum is nothing but a band of colors. Okay, spectrum of white light is the sequence of colors obtained on dispersion of light. This is your spectrum. This is the spectrum of band of 7 colors. Okay, this is the spectrum. Next, so just now we have discussed why do we get different colors when light pass through the prism, because each light will have different wavelength, so the angle of deviation will be different, so it will be deviated separately so that we can able to see the 7 different colors. Different colors of light bends through the different angles with respect to the incident ray. Okay, based on their wavelength as they pass through the prism. That's why we are getting different colors when a light is passed. White light is passed through the prism. Mention the word white light because only white light contains 7 different colors. Okay, it's composed of 7 different colors. Okay, then. So you know that which one will bend more? Violet color, because it has a minimum wavelength, right? So maximum deviation, which one will do? Violet color. Violet color will bend most and it has a maximum deviation, angle of deviation, and the red light bends the least, it has a minimum deviation. Okay, then. So this Isaac Newton, that he is the one to first use a glass prism to obtain the spectrum of sunlight. Spectrum of sunlight means what? A sunlight is a white light. When it passes through the glass prism, he will get the band of colors, 7 colors, right? Sequence of colors. Okay, that is the spectrum of sunlight. He is the first person to use this, and he got the spectrum of sunlight. Okay. What he did means he tried to further he passed the white light through the prism. He got a 7 colors. Then he tried to keep another prism like this, and he further tried to split all this thing, but it doesn't work out. Okay, it does not split further. Okay, Again he got the same 7 colors. Okay, so what he did means he used the same prism, okay, but in an inverted position. First prism, he has passed the white light and he got the 7 different colors, right? I just draw this red and violet alone. Okay, this is a white beam and you'll get this is your violet color. Okay, this is your red and this is your violet. Okay, so what he did, he kept the similar type of prism in an inverted position. Okay, inverted position. For the convenience, I draw this is your red light because its angle of deviation is very less, and this is violet light, the angle of deviation is more. Okay, so since it is a similar type of prism, so the pair of medium, that is air to this glass and glass to this air, will have the same type of refraction, right? The amount of deviation, refraction, amount of bending of the light will be same. Because refractive index is same for both the prism. So what happens? Again he get this would be your normal, you will get the refraction like this, deviation of the light like this, and he got a beam of light again. This is a white light. This is a white light, sunlight. Okay, white light from the sunlight. Okay, so what he did, he kept the prism in the inverted position. Again the dispersed light is passed through this prism and he got a beam of white light. Then only he found that sunlight consists of 7 different colors, that is white light. Any color which consists of the sequence of 7 colors, then we call it as a white light. Okay, this is the recombination of the white light. Okay, this is what happened in that experiment. So first Newton split the white light into spectrum by passing it through a glass prism. Okay, then he placed a second identical prism in an inverted position with respect to the first prism. He found a beam of white light emerging from the other side of the second prism. This observation shows that sunlight is made up of 7 different colors. Clear? This is the diagram of recombination. This is arrow and this would be your arrow. Same angle of deviation. If it is, for example, 10 degree deviation from the incident enemy, here also the same 10 degree will be deviated. Here it is 50 degree, means here also this violet light will undergo 50 degree deviation. Okay, that's why you use a similar type of prism. Okay, thank you.